Alright guys, what I'd like to do is to give you a little tutorial on the sum and difference of cubes. I think where the biggest problem lies is the misunderstanding of what a cube actually is. So if we took a number and assigned it a letter, like say A, and I'm going to assign A to the value of 2. Well, then the value of A to the third is saying 2 to the third, or 8. Being able to recognize the cube root of 8 then as 2 is going to be critical in this section of the book. Also, if we took A and we said that A was x, well then A to the third would be the same as raising x to the third power, which is x to the third. But more importantly, say A was say x squared, then A to the third would be x squared raised to the third power, which we know as x to the sixth. Let's try a few more examples. Now say you started off with a value of A to the third equals 27. So if A to the third was 27, what was the value of A to begin with? Well, what value do you raise to the third power to get 27? Or what is the cube root of 27? And that value is 3. Now we step it up a notch and we look at A to the third as 8x to the third. And again, we just have to ask ourselves, well, what is the cube root of 8x to the third? But now I'm looking at things separately. I'm looking at the number 8, the cube root of number 8 is 2. The cube root of x to the third is simply answering the question of what do I raise x to get to x to the third? I raise x to the first to the third power to get x to the third. Now we move on to if A to the third is equal to x to the ninth. And so at this point, perhaps if I think about it like this, I want to get an answer of x to the ninth. What power of x do I raise to the third power to get to the ninth? So the answer to that is 3, because my x to the third raised to the third, according to our exponent rules, I would multiply these two numbers. So 3 times 3 is equal to 9. Therefore, my A is equal to x to the third. Using that knowledge down at the bottom here on our last one, I look at this separately and I say, well, if I have 64x to the 12th, the cube root of 64 is 4. And the cube root of x to the 12th is the number that I would multiply times 3 to give me 12, which is x to the 4th. Taking all of this newfound cube knowledge, I now can answer questions like, how do you factor 125n to the third plus 216? The key piece is to follow this pattern as indicated above. If we have a to the third plus b to the third, that breaks down into a two-part factorization. A plus b times a squared minus ab plus b squared. Notice that this whole thing relies on me, or my ability rather, to identify what a and b are. So that's the first trick of the game. So looking at 125n to the third, using from the previous slide, using my knowledge, I'm going to look at 125 and understand that the cube root of 125 is 5, and the cube root of n to the third is n. Therefore, my value of a is 5n. And again, if you think about it in reverse order, if you raise 5n to the third power, you're going to get 125n to the third. B, therefore, is a value of 6. So now I'm just going to use or copy, essentially, this factorization formula from the top, substituting in my values of a and b respectively. So a plus b now is going to be equal to 5n plus 6. Now my a squared is going to be 5n squared, and 5n times 5n is 25n squared, minus a times b, so that's 5n times 6, which is minus 30n, plus b squared, which is 6 squared, plus 36. Just kind of squeezing that in there. With, again, understanding that this whole piece here is 5n all squared, and this piece right here was 6 all squared, and the minus 30 came from 5n times 6. Lastly, we have our difference of cubes. Right? This is a difference because it's a minus. And so the difference of cubes follows the factorization pattern of a minus b times a squared plus ab plus b squared. Once again, looking at our a to the third minus b to the third piece here, I want to identify who a and b are. So a is going to be 3a. 3 to the third gives me 27. A to the third gives me the a to the third. And b is equal to 10. So now I'm just going to follow my pattern, and my a minus b then is going to be 3a minus 10, and then my a squared, right, my a squared is going to be 3a squared, which is 9a squared, plus a times b, which is 3a times 10, so that's going to be plus 30a, plus my b squared, and my b is 10, and I'm going to square that, so that gives me 100. And so my factorization is sitting right there. Piece of cake.